part A's here. So one strategy you learned is to look for a greatest common factor, and that is what can you pull out of each term of the quadratic. So 2x squared and 20x, I can pull a 2x out of each of them evenly. So that's called the greatest common factor. And then what you're doing is you're dividing each term by the 2x and seeing what you would have left in the parentheses. So this one would factor into 2x times x plus 10. And that should be the first thing that you always look to do for any quadratic that you're factoring is what can I pull out? And then when you look at number 2, difference of squares, I can't divide those by anything, right? I can't pull something out of both of them, but the perfect squares are 1, 4, 9, 16, 25. So x squared with a coefficient of 1 is a perfect square. Over here, 4x squared, 4 is a perfect square. 100 is a perfect square. 25 is a perfect square. So your brain starts to recognize, oh, these are perfect squares. It says it's difference, meaning subtraction. And the reason for that, when you factor the formula for difference of squares, it factors into basically the square root of each term, with 1 gets a plus and 1 gets a minus. So x times x is x squared, and 10 times 10 is 100. And the reason that 1 gets the plus and 1 gets the minus, hopefully you remember FOIL, or multiplying out the binomials. When you do your outer term plus your inner term, they're opposites. So negative 10x and positive 10x is 0. And if you notice in the original part, there's 0 x's showing up. So difference of squares should be something that rings a bell. And it says, can you factor the sum of two squares? No, that's prime. If you tried to do like x plus 3, you would get a 6x term for the middle. And so it's not factorable, it's prime. Perfect square trinomial. Some of you might have learned how to factor it in your head. Some of you might use the diamond method still. I don't care which method you use. You're looking for the factors of 16 that add up to -8, and you know that the first two terms have to be x's. And if you want to remember the diamond method, you put your 16 up in the top and your -8 down in the bottom. So you're looking for the factors of 16 that add up to -8. Did you guys learn the diamond method a lot? Or, oh, okay, so that's familiar to you. Depending on where you learned how to factor, you might have just done it in your head. Like I know that -4 times -4 is 16 and adds up to -8. So x minus 4, x minus 4. See how when you do your outer plus your inner, you get your -8x. And I just classified this as a perfect square trinomial because if you wanted to, you could write your final answer as x minus 4 squared, but either of these is the correct answer. So I'm just going to do 4a and 5a, and then maybe you can try like 4b and 5b if we have time. So this is just another trinomial again. A is 1. It's just not going to come out as perfect square trinomial. So what are the factors of 40 that would add up to 14? Right? The factors of 40 that add up to 14. And you know that this is x and this is x. So what would my factors have to be? You can go through all of them in your head, right? 1 times 40, 2 times 20. Yep. Yep. 10 times 4 is 40. And adds up to 14. So x plus 10, x plus 4 are the factors. So I like these. And then the next page is the last strategy that tends to be the most difficult. It's when the a value is bigger than 1. And you can use the box method and the diamond method or the grouping method. But as advanced mathematicians, if you can do it when it's prime in your head, you'll do it so much faster. 3 is a prime number, right? So is 2. Now, when they get a little bit bigger in front, maybe that would be harder. But if it has to be 3x squared, doesn't it have to be 3x times x? It has to be, right? Or x times 3x. That's locked. It's not like I could pick a 2x and a 4x, or it has to be one of them gets a 3x and one of them gets an x. 5 is also a prime number, 5 and 1, right? So your only possibilities are one of these is going to have to be a plus and a minus, so you're going to have to figure that part out. But one of these positions is going to be a 5, and one of these positions is going to be a 1, and you've got to figure out which outer plus inner gives you negative 14. So I always learned factoring in my head, but we baby stepped you in Algebra 2 to teach factoring to you. So I'm going to show you the box method in just a second, but do you see how if you put the negative 5 here, it's going to multiply by the 3x when you do your outer? So you'd have negative 15x's, and then plus 1 more x when you do your inner would give you the negative 14x that you want. So if you didn't get the box method in the past, you're a little bit more mature now in your computing abilities. You might be able to just factor these by doing kind of your outer and your inner in your head and save yourself some time. Some of you like puzzles anyway. It's really a puzzle. Maybe I'll just, for the last one, I'll show you the box method on this one. And then that way I won't go back and do the box method here. So the box method is when you put your starting term 2x squared in the top left, and you put your 4 in the bottom right, and you evenly split up, or you split up the 9x into the other boxes. But to figure out where to put the 9x's, like do I want to put 6x's here or 7x's here, you do the diamond on 2 times 4. So 2 times 4 is 8, and they have to multiply to 8 and add up to 9. So the factors of 8 are probably going to be 8 and 1, right? Because 8 times 1 is 8, 8 plus 1 is 9. You can put them either box. So I'm going to put 8 of my x's in one of the box and 1 of my x's in this other box. And do you see how that's your 9x's? So these 4 terms just represent your starting trinomial arranged so that it's easy to factor. So the box method just allows you to factor. Now you're looking for what goes on the outside of the box so that when you multiply them together, you get the things on the inside of the box. So like I was doing over here, I knew that 3x times x would give me 3x squared. Well, 2x times x will give me 2x squared. I strategically put the 2x over on the left because I can see that I need to get an 8x over here, but I only need to get a 1x down below. So you might have to play around with where to put those. And then do you see how this would be a plus 4 over here? Because 4 times 2x is 8x, and this would be a 1 right here because 1 times x and then 4 times 1. This is supposed to say a plus. So your final answer, 2x plus 1 times x plus 4. Did most of you do the box method in Algebra 2?